Hi guys, welcome to Electronics to the Point. In this video, I'll explain you how to find whether digital counter counts up or down sequence. Okay, first of all, let us go to basics and get into the main topic. Actually, what is meant by counter? Counter is nothing but a cascade connection of two or more flip-flops. Okay, remember this point. And there are two types of counters. First one, synchronous counter. Second one, asynchronous counters. Synchronous counters are nothing but the clock is given to the first flip-flop, second and third simultaneously. Okay, parallel clock is given. Okay, in synchronous counters, we can find we can find the count sequence either from up to down or from down to up, or random sequence can also be found. In a sense, if we start an up count, we can get up count from 0 to 7, 0 1 2 3 4 5 6 7, and we can obtain down count from 7 to 0. Okay, and a random counter can also be obtained. In a sense, for example, 3 to 7 count we require, we can obtain by connecting respective connections. Okay, what is meant by asynchronous counter? Asynchronous counter is nothing but, first the point to be remembered is, asynchronous counters are the clock given to the first flip-flop and the clock of the second flip-flop is obtained from the output of the first flip-flop. Okay, this is the logic for asynchronous counters. In asynchronous counters, we take the inputs given in toggle mode, that is JK or T. Okay, from the knowledge of sequential circuits, we can say that in JK flip-flop, when toggling of input occurs when JK is equal to 1, right? JK 1, JK 1, and in toggle mode, when input is 1, the output gets toggled. Okay, example for asynchronous counter and synchronous counters. First, synchronous counters example is ring counter, and for asynchronous counter is ripple counter. Okay, now we will consider asynchronous counters and we will determine the count sequence for it. Okay, start. How to identify whether digital counter counts up or down sequence? Guys, please remember this logic I give to you. Okay, remember one thing. See, down up up down, this counts. How to identify the counter, if it counts up or down sequence, it lies in this logic. Remember this logic. We know for two variables what is the possible combination of input. If we are given with two bits 0 1 or something, possible input combinations are 0 0 0 1 1 0 1 1, right? What we do is, the first point to be remembered is whether, if you are finding the how to find whether this count is up or down, we have to see first how the clock is triggered, either negative edge triggered or positive edge triggered, and what I said, the output taken from the clock. See, okay, in this, let us take 2-bit triple counter. See, Q0, Q0 bar, Q1, Q1 bar. Let us take clock from here. Okay, J, K, J, K, operating in toggle mode. Okay, now if the we have to find the whether it counts up count or down count. Okay, now see, remember this logic: 0 0 0 1 1 0 1 1. Okay, first column, consider this as clock, whether clock given negative edge or positive edge, and considers the second column as from where the output is taken. See, Q0. Okay, Q0, Q0 bar. You assign the second column to where the output is taken, and you will find easy to identify the count sequences. See, 0 0 0 1 1 0 1 1. First column what we have taken is triggering. For 0, let us consider is negative. In digital logic we consider 0 as negative, right, and 1 as positive. So 0 negative edge, 0 negative edge, 1 positive edge, 1 positive edge, and output 0 1 0 1, right. Consider 0 as we take output from Q0 or Q0 bar. Let us take Q or Q bar. Okay, if there is 0, consider it Q bar. If there is 1, consider it Q. Okay, now it will be quite easy for us to identify. Okay, and remember this part you have to remember. This is logic and you can easily remember this. First column as clock, second column as where the output is taken, and the output is taken and given to clock, right, as clock to second flip-flop, right. See, now identify for this whether it counts down or up. See, it's easy, right, down up up down, it's quite easy, right. Now identify for this so that you will get some experience on it and you get some clarity. Okay, clock given is positive edge ticket, right, and where the from the output is given Q0, right, it's positive. What clock Q0, positive positive, clock negative, a positive edge triggered, positive edge trigger, right, positive edge, positive Q, so it counts down sequence. Okay, now let us take second example. This is 2-bit triple counter. Let us give negative edge trigger. Okay, Q, Q bar, Q0, Q0 bar, Q1, Q1 bar. Okay, now let us give output from Q0 bar. As we have given negative edge trigger, whenever we take output we have to make here a bubble. Bubble represents negative edge triggering. Okay, now let us identify. If you want we can give another one, another flip-flop, and it makes 3-bit triple counter. Okay, in this, okay, connect this, fine, J, K, toggle mode, right, as we have considered an asynchronous flip-flop. Q2, Q2 bar. Now identify the whether it counts up or down. See, given negative edge triggered and output is taken from Q bar, right. See, where do we find the sequence? Negative edge trigger and output taken from Q bar. Negative edge trigger, output taken from Q bar, right. See the logic, negative Q bar, it's down counter, so it counts down sequence. Okay, likewise we can find this for any circuit given. Okay, in next video I'll explain you how to identify and how to get the mod number. Okay, how to identify the mod number for a given counter. It's important, and stay tuned. Thank you.